Good morning, I am Ruta Bendre. Today we will be studying about the logical instructions in 8085. Now what do you mean by the logical instructions? The instructions which perform any logical operations like ANDing, ORing, XORing, or for example complementing, comparing, or rotating, that is shifting, etc. These are nothing but the instructions which come under the logical instructions group of the 8085. Most of these instructions will affect the flag register in 8085, and one of the important rule is one operand must be in the accumulator and always the result is stored in the accumulator after any logical operations. So these are the rules which you have to follow while writing the logical instructions. Now let's see which are the logical instructions. The first instruction is nothing but ANA instruction. This particular instruction represents the AND operation. AND operation means what? When both the inputs are 1, output will be 1. When A and B are 1, output will be 1. That is the logic of the AND gate. Okay, so same logic we will be using in the instruction. When you say ANA, R or M, then it will AND the contents of the register or the memory with the accumulator. The result will be stored in the accumulator. Now all these instructions, that is AND instruction, will always set the auxiliary carry flag even if it is not in the answer. It will reset the carry flag. All other flags will be affected according to the answer. Now let's see one example. Suppose if I say ANAB, we assume that if suppose B register has 06 and A register has 0A. So 06 is represented in this manner, 0A is represented in this manner. Now any bit is 0, output is 0. So 01 is also 0, 10 is also 0, but 11 the output will be 1. And 000. So the 02 is the answer which will be there in the accumulator. Now according to the answer, the sign flag, that is the MSB of the answer, is 0. The answer is non-zero, therefore 0 flag is 0. But ANA instruction compulsorily sets auxiliary carry flag. So even if the auxiliary carry flag is not there, the auxiliary carry flag will be set. Then the number of ones in the answer are odd, therefore P flag is 0, that is parity flag is 0, and carry also is resetted by the ANA instruction, therefore carry flag is 0. So the flag register contents will be 10 in this case. Similarly, when you say ANAM, the memory contents will be ANDed with the accumulator. Now when do you talk about M? The address must be in the HL register pair. So if HL register has 6000, this 6000 will act as an address, okay, and the contents of this 6000 are 35. So M represents 35, and suppose A is 0A, then after ANA instruction we will find that A becomes 00. Okay, so now we will have to see what can be the flag register content. So think about it and find out what will be the flag register contents. Okay, these all are 1 byte instructions. If it is ANAM, then it is indirect mode of addressing, and if it is ANAR, it is register addressing mode of the instruction. Now similar to this, suppose if I don't have the number in the register, if I have actual number to be ANDed, then I can use the ANI instruction. So ANI and then 8-bit number. This 8-bit number is ANDed with the accumulator and the result will be always stored in the accumulator. Again, this is a 2 byte instruction. It is an immediate addressing mode of instruction. And auxiliary carry is set and carry is compulsorily reset in this case. Now if it is ANI 78, now 78 is nothing but this. If accumulator has F2, then it is F2, and ANDing operation when both the inputs are 1, output is 1. So wherever both the bits are 1, the output is 1, rest of the bits are 0. So you get 70 in the accumulator. Now this is regarding your AND instruction. Similarly, when I have the OR operation, we have ORA, correct? ANA, instead of that you have ORA, that is OR the contents of the register or the memory with the accumulator. Now you know what is the OR gate output. When both the inputs are 1 or one of the input is 1, the output is 1 in the case of OR gate. So same logic we will be using for this particular instruction. Now these instructions will compulsorily reset the auxiliary carry and carry flag. So ORAB, if I say if B is 6 and A is 0A, then 06 and 0A are odd. Any one bit is 1, output will be 1, rest of the time it will be 0. So 0E is nothing but the contents of the accumulator. And from this answer, the flag register will be sign flag 0, 0 flag 0, auxiliary carry 0, carry is 0 and parity odd asल्यामुळे parity will be 0. Hence the flag register contents will be 0, 0. If it is ORAM, then the memory contents will be odd with the accumulator contents. Memory contents means what? HL मध्ये जो address, whichever address is there, the contents of that address will be odd with the accumulator. So if HL has 6000, we are assuming these numbers, right? And 6000 has 35, and suppose A is 0A, then 0A and 35 will be odd. You check whether you are getting the answer in the accumulator as 3F. Okay. Now again, we know that auxiliary carry and carry will be resetted. You have to find out what will be the flag register contents in this case. Now similarly, if I have an 8-bit data, it will be ORI, ANI, ORI, right? ORI and then 8-bit numbers. The 8-bit number will be odd with the accumulator. So whatever might be the 8-bit number which is mentioned in the instruction, that is 78 is the number which is mentioned in the instruction, will be odd with the F2. So if you see, when one of the input is 1, output will be 1, or both the inputs are 1, output will be 1. So in this case, you get FA is the value in the accumulator. That is the result in the accumulator. Find out what will be the flag register contents. The third logical operation, which is nothing but XRA, that is XOR gate wala operation. Now in case of XOR gate, what is the output? When both the inputs are different, output will be 1. Or odd number of inputs are 1, output will be 1, actually speaking. But just here we are considering only 2 inputs. Just easily you can remember, when both the inputs are different, the output is 1. So XRA R or M will XOR the contents of the register or the memory with the accumulator. Again the auxiliary carry and carry will be resetted. Okay. Now XRAB, same numbers we will take. For example, B has 06, A has 0A. Then what will happen? See here, when both the inputs are different, output will be 1. When both the inputs are same, output will be 0. Therefore, accumulator contents will be 0C. And from this answer, the flag register contents will be sign flag 0, 0 flag 0, auxiliary carry 0. Parity should be 1 in this case. Parity should be 1 because even number of ones are there in the answer, and carry is 0. So actually the answer will be 04 in this case. Okay, in the flag register. Similarly, XRAM, if you see, the memory contents will be XORed with the accumulator contents. So find out what will be the XOR operation when the memory contents are 35 and A contents are 0A. So what will be the contents of the accumulator? Just find out here. XRI instruction. Similarly, when I want to XOR the 8-bit number with accumulator, I will use XRI instruction. So whatever is the number specified in the instruction will be XORed with the accumulator. So if A is F2 and then F2 and 78 will be XORed, and then we will have to see what are the contents of the accumulator. So this is your 78, this is your F2. When both the bits are different, the output is 1. So here, and here the output is 1. Rest of the bits will be 0 because both the bits will be same. Now find out what will be the flag register contains. Now the next instruction is nothing but CMA. This is nothing but it acts as a NOT gate. Usually when you want to invert the input, we use the CMA instruction. Now CMA instruction, in this case the number is assumed to be in the accumulator. Okay, and that accumulator contents will be complemented. The answer will be stored in the accumulator. No other flags are affected. None of the flags are affected with this particular instruction. And the addressing mode of this instruction is nothing but implicit or implied mode of address. So if A is 10, 10 means actually 0001, 0000. So each bit will be complemented. So 0 ka 1, 0 1, 0 1, 1 it will become 0. These 0 will become 1 and hence the accumulator contents will be EF. So this is one of the CMA, that is complement accumulator, is the logical instruction. Now next instructions we will study in the next part of the video. Thank you.